Periodic trends in chemical properties. First one is oxidation state. So the atomic property valency is better explained in terms of oxidation state. Okay, valency can be explained in terms of oxidation state. Okay. Now, what is oxidation state? It is a charge which an atom of an element has when present in the combined state. It is the, so oxidation state is the charge of an atom, charge of the atom of an element has when it is present in the combined state. Okay, that is in the case of chemical compounds. Okay, the atoms are having a particular charge. Okay, this charge is called as oxidation state. Okay, so electronegative elements have negative oxidation state and electropositive atoms have positive oxidation state. Let us take two examples. OF2 and Na2. Na2O. How can we explain the oxidation state of the atoms present in this chemical compounds? First, let us take OF2. F is having the electronic configuration 1s2, 2s2, 2p5. Okay, so this requires one more electron to complete its octet. Okay, so next oxygen 1s2, 2s2, 2p4. So this atom requires two more electrons to complete its octet. Okay, so the compound will be like this. Okay, like this. Okay, this fluorine will share one electron. Here the fluorine is more electronegative atom compared to oxygen. Okay, so fluorine shares one electron to the oxygen. So it gets -1 charge. Here also the same. But this oxygen requires two electrons. So it shares two electrons with the fluorines on both sides. So it gets +2 charge. Like this, we can explain the oxidation state of elements. Now, let us take Na2. Oxygen is having the configuration this. So it requires two more electrons to complete the octet. Sodium, the electronic configuration is 1s2, 2s2, 2p6, 3s1. So it requires one more electron to complete its octet. Okay, so oxygen, sodium, sodium. Here we know oxygen is more electronegative and sodium is electropositive. Okay, so here it shares two electrons to the two sodium atoms, so it gets -2 charge, and this sodium shares one electron to the oxygen, it gets +1 charge. Same here also. Okay, so like this we can explain the different oxidation states of elements in a compound, in a chemical compound. Okay. Now some of the hydrides and oxides of third group elements are given. Okay, so how can we calculate the oxidation state of those elements? First, NaH. Here hydrogen is more electronegative, so sodium +1, then magnesium +2, then aluminium +3, then silicon +4. Next, in the case of pH3, phosphorus is more electronegative. Okay, so hydrogen is having +1 oxidation state, so here -3. Sulfur is more electronegative, so -2. Then chlorine is more electronegative, -1. Now in the case of oxides, oxygen is more electronegative than all the third group elements. Okay, so all oxygen is having -2 oxidation state, so +1, then here +2, then +3. Okay, oxygen -2, so +4, then here +5, then plus 6 and plus 7. Okay, so these are the different oxidation states. Okay. Second property is anomalous properties of second group elements. So the first elements of S and P block elements differs in many respects from the remaining members of the respective groups. So first members of S and P block elements. Okay, so the reason for this is due to small size, high charge by radius ratio, high electronegativity, and availability of less valence orbitals. Okay, less valence orbitals. For example, in 13th group, boron is the first element. Okay, so in this case 2s and 2p. 2p contains 3 orbitals and 2s 1 orbital. So 4 valence orbitals are available for bonding. Only 4 valence orbitals are available. But from the second element onwards, 3s, 3p and 3d. So total 9 valence orbitals are available for bonding. Okay. This is an example in the case of 13th group. Okay. So for example, Bf4 minus. Boron bonds with 4 fluorine atoms. Okay. Aluminium Al(F6). Okay. 3 minus. So aluminium is having plus 3 oxidation state. Okay. And covalency is 6. So in the case of higher members, more valence orbitals are available for bonding. Okay. This is one of the anomalous property of boron in the 13th group. Next group, that is 14th, 15th and 16th group. First elements are carbon, nitrogen and oxygen. These are having anomalous properties, that is they form p-pi multiple bonds. P-pi multiple bonds compared to the other elements in the respective group. Okay. So example, in the case of carbon, it forms C triple bond C, C double bond C, then N triple bond N, then C triple bond N, N double bond O, etc. Okay. Then next property is diagonal relationship. Diagonal relationship. That means lithium, the first element in the that group, the first group, resembles magnesium in the is the second element in the second group. Okay, is the second element in the second group. Okay, so there is resemblance between these two groups in many properties. Okay, this property is called as diagonal relationship. Okay, this property is known as diagonal relationships, that is lithium resembles magnesium. Okay, diagonally they are related. Okay, next another example is beryllium. Beryllium is a first element in the second group. Okay, it resembles to aluminium, second element in the group 13, in 13th group. Okay, there is also these two atoms are resembled. Okay, these two elements, the first element and the second element in the next 13th group are resemble to each other. This property is known as diagonal relationship. Okay. Next, chemical reactivity of elements. Across a period, ionization energy increases from left to right. Okay. Then, except noble gases, also negative enthalpy, negative value of electron gain enthalpy also increases. Okay. So, the elements at the extreme left has low ionization energy, that means they are highly reactive. Okay. And those at the extreme right have high ionization energy, they are also highly reactive. Okay. So, the elements at the two extremes are highly reactive compared to those at the center. The center elements will have moderate reactivity compared to the two extreme elements. Okay. Next, elements at two extreme, that is Na2O, form oxides. Okay, two extreme, and chlorine Cl2O7. Okay. They form oxides. So, elements at the two extremes can form oxides, and Na2O is most basic, whereas Cl2O7 is most acidic. Okay. And the compounds in between at the center are called as amphoteric. For example, Al2O3 is amphoteric, or they may be neutral. Example, carbon monoxide, NO, these are neutral. Okay. These are the reactivity in the periodic table. Next, in the case of transition and inner transition elements, ionization energy are intermediate between S and P block elements. Okay. Intermediate. In transition and inner transition elements, they are intermediate between S and P block elements. And so, electropositivity, then metallic character, all these are also intermediate between S and P block elements. Okay. Now, a brief study of the different physical properties in the periodic table. We already discussed those things. Okay, we have a brief study on this. First, in the case of a period, from left to right. Okay. Then reverse will be in the case of group. So, study any one of this period or group, the reverse will be the other one. Okay. So, first one is atomic size. Atomic size decreases from left to right. Okay. Then second, what will happen to ionization energy? Ionization energy increases from left to right. Then third one, negative electron gain enthalpy. What will happen? Negative electron gain enthalpy increases. Okay. Negative electron gain enthalpy increases. Then what will happen to electronegativity? Electronegativity also increases from left to right. Increases. Next, what about metallic character? Metallic character decreases from left to right, or non-metallic character increases from left to right. Okay. So, in the case of a group, reverse will be the order. That is, atomic size increases, ionization energy decreases down the group, negative electron gain enthalpy decreases down the group, the electronegativity decreases down the group, whereas metallic character increases from top to bottom. Okay.